So moving on from just simplifying radicals to adding and subtracting them. Like I mentioned in section 6.1, something that was going to come up is the idea of like terms with radicals. I have that exact same picture here about what qualifies as like and what qualifies as unlike. But the key thing here is that in order to add or subtract, we must have like terms. There is no option. We cannot add or subtract without like terms. Once we have them, it becomes like adding and subtracting with variables. So, looking at question A, we have root 50 plus 3 root 2, which we do not have like terms. We have a root 50, we have a root 2. So what we need to do is take these and simplify them down as far as they will go, and hope that we get like terms out of it. I'm going to do that off to the side, just so that we don't get things confused. So, root 50. We need to prime factorize it. 50 is divisible by 2. We get 2 times 25. Looking at 25 now, it's not divisible by 2. Check if it's divisible by 3. It's not. Check if it's divisible by 5. Yes, it is. It is 5 times 5. And just like that, we are fully prime factorized. Look for pairs. Since this is a square root, we have a pair of 5s that can come out, and root 50 is equivalent to 5 root 2. Now that we have the equivalent form of 50 as a mixed radical, we can take that and we can put it back, substitute it back into the original expression. So instead of root 50, we have 5 root 2 plus the 3 root 2, which we don't need to simplify at all since it's already mixed and in simplest form. And we do now have like radicals. We both have sets of root 2. So to add this would be exactly the same as if it was 5x plus 3x. Add the coefficients. 5 plus 3 would give us 8. The root stays untouched. We have 8 root 2. I'll clear out the page for question B. This one is a little more complicated only because we have a significant number of roots. So we'll have to do quite a bit of side work in order to get these down to like terms. Do that off to the side here. We have root 27. I'm not going to worry about the negative because we can just insert that later. 27 to prime factorize. It's not divisible by 2, but it is divisible by 3. So it would be the same as 3 times 9. Looking at the 9, it's also divisible by 3. We get 3 times 3 times 3 out of that. Pair of 3's we can take. So 27 is equivalent to 3 root 3. And when we go and substitute that back in, which I'll do right now, we had negative root 27, so this would be negative 3 root 3 here. Next term there is 3 root 5. 5 is already prime. We can't break it down any useful ways, so we'll just carry it forward. Next is root 80. We have to prime factorize it, and just in the interest of saving a little time, we'll shortcut that a little bit, excuse me. 80, it's divisible by 2. And if we just hold this in our head, this would be the same as 2 times 40. That 40 that I haven't written down, but would be there, is divisible by 2. So we're at 2 times 20. We're sitting at 20 here invisibly, which is divisible by 2, which sits us at 10, which is divisible by 2 again, which sits us at 5. Now you might be thinking that's quite a bit to hold in your head as you're breaking it down, but there's always a foolproof way of figuring out whether you've prime factorized this correctly. Take the breakdown that you have, 2 times 2 times 2 times 2 times 5. If that works out to the original number, the 80 in this case, then you have factored it correctly. And lo and behold, it does, so we have. If you haven't, write it out step by step like with the breakdown of 27. It takes a little bit more time, but it's definitely a little more foolproof. Looking to simplify this now, we look for pairs because it's a square root, pair of 2's, second pair of 2's. So we would have 2 times 2, and root 5 is left over, which would be equivalent to 4 root 5. So back over here in the original expression, minus root 80 would be minus 4 root 5. One last radical to break down, that 2 root 12, and I am going to put the 2 in here because this does change things a little bit. Not much. So we have the 2, and we break down the 12. It's divisible by 2. It would be 2 times 6. And again, I'm not going to write the 6 down. I'm just going to keep it in my head. 6 is divisible by 2. It's 2 times 3, which is fully prime factorized. Give it a double check. 2 times 2 times 3 does give you back to 12, so we are good there. Looking for pairs under the root to take out. Pair of 2's. Which that pair of 2's, when it comes out, is going to multiply into the existing 2 that was there. So we get 2 times 2 root 3. That 2 carried down. Those 2's came out to give us that one, which would simplify out to 4 root 3. So minus 2 root 12 is equivalent to minus 4 root 3 back over here. Now, looking at this, we don't have full sets of like terms, but we do have a couple of pairs of like terms. We have negative 3 root 3 and minus 4 root 3. We have 3 root 5 and minus 4 root 5 that are also like terms. So we can do a little bit of simplifying, but we can't get this down to one single term. We can get it down a little simpler than it is now. So looking at the root 3's, we have negative 3 root 3, and at the end minus 4 root 3. Add the coefficients. Negative 3 plus negative 4 would give us negative 7 root 3. And the root 5's, we have 3 root 5 minus 4 root 5. 3 minus 4 would give us negative 1 root 5. But as with variables, we don't put a coefficient of 1. So a better way of putting this, a more simpler way, negative 7 root 3 minus root 5. Clear out the page for question C. We have square root of 4c minus 4 root 9c, and you'll notice after that we have a condition attached to the variable, and that c has to be greater than or equal to 0, also known as c has to be a positive number. That is only there because we have a variable under the root, and as we know, we can't take the root of a negative, so this is just a condition saying that we have to have some positive under there. We don't have like terms, so we need to look at simplifying. We have square root of 4c Prime factorize the 4, which would be 2 times 2. Break down the exponent on the c if there was one. There isn't. Look for pairs, pull them out. We have a pair of 2's. So square root of 4c is equivalent to 2 root c, which I'll put back in here. Second term we have is 4 root 9c. Four is going to hang out here. Let's factorize the 9. It's 3 times 3. Again, no exponent to break down the c. Find pairs, pair of 3's. When it comes out, it'll be 4 times 3 with the root c left over. Simplify that down, it would end up being 12 root c. Fill that in back over here, so 4 root 9c is equivalent to 12 root c. We do have like terms now, so we can just combine the coefficients. 2 minus 12 give us negative 10 root c.